Right. In today's lecture, we are going to talk about oil and gas as the one of the key resources in the world. Right. As we all know, um, and we cannot live without this resource. But let's talk very briefly about the background. What are these resources, and then how it is important, why it is become a marine resource, right? So um, in general, the oil and gas is considered as the black gold, and so it's like a gold mine, because there's a huge money um, in this resource, behind this resource, right? Saying that's this is one of the most traded commodities in the world as well, right? That's why it's called black gold, right? Um, so what are the what are we going to talk in this lecture, right? The little bit of the origin of oil and gas. Perhaps some of you might have already discussed a little bit on this topic, but I'll go a little bit further into that. Then how this oil is being explored in the ocean, right? And a little bit of the politics as well on the something to do with the oil and gas, right? All right. So if you begin with the chemistry, as we all know, the oil and gas, or rather oil, is actually some sort of a hydrocarbon, right? Which means the hydrogen bonds, carbons are bonded with the hydrogen bonds. So that's how the basically the oils are made of, right? So the backbone is the carbon and the hydrogen bonds, right? And forming this the unique chemical, what we call the hydrocarbon, is a polymer. And here you can see in the left side crude oil, right? Boratel, right? Usually called as boratel. This is the crude oil, and unrefined form. There are whole mixture of chemicals. That's the unique thing with this crude oil. Actually, it's the whole mixture of different types of chemicals. And if you go back to the origin, right? So as you may already aware, the origin of the oil come from phytoplankton and zooplankton, or otherwise we can call the microscopic plants or animals, right? And how these are formed, we know that the time to time there can be a huge sort of blooms that form in the ocean, especially in the upwelling area, right? You know what is upwelling areas. In some areas, due to very high upwelling, there can be huge plankton blooms, right? And then especially when the nutrients stir up due to the upwelling, and this plankton blooms making a huge layer of planktons, and this plankton, and once they are in a huge bloom, we know that they might not get enough oxygen or necessary things for them to live, so they eventually die, right? And once they die, they will be settled in the bottom, in the large layer of phytoplankton or zooplankton, whatever the plankton, right? It can be a couple of meters or even thicker than that. It can be huge, and this process could have been happened in many times in the history, and making a huge layer of plankton blooms, right? You might not think how large these plankton blooms can be and this layer of sediment can be, right? And eventually, on top of this dead plankton layer, right, there can be a deposition of sediments, right? All the other sediments will deposit on top of this layer, right? And sometimes can be several meters or several 100 meters to even sometimes a couple of kilometers down, right? Because, and we are talking about not hundreds of thousands, but millions of years, right? To make this process going to be millions of years, and throughout there can be a thick layer of sediments on top of this plankton blooms or the dead plankton blooms or the layer of plankton, right? And now when the I mean, of course, this plankton will be not the pure plankton or the sediment layer, but there will be a mixture of the other sediment and the plankton, dead plankton, right? And eventually, with the pressure from the water as well as from the any sediment above, they are going to be a compact and become some sort of a sediment layer. So it becomes a part of the ocean floor or the sediment, right? When the organic content of this sediment layer is above 5%, right, and then the scientists call this as black shale, right? It's called the black shale. The picture, the below you can see some layer here, but of course visually you won't notice any difference, but there is a layer here, and that's supposed to be a black shale where with this very high organic content due to the plankton bloom, right? Now, once these the layer, they are in the deep ocean, right? They are already buried in the deep ocean, and you know, when these are buried with the high temperatures from the ocean floor, right? They are get heated. You know when the bottom and the center of the ocean is very warm. This layer also getting warmer with that the temperature underneath, right? And now the chemical I mean, they start degrading and their chemical composition also change with time, right? So initially it's just the plankton or dead plankton, then they can become, when they are digested, they become organic matter, right? And this organic matter under high pressure and high temperature, they change into a different chemical, right? The earliest version, like the first change is called the kerogen, right? And it's sort of a solid form of hydrocarbon, right? It's like a solid, right? And that's called the kerogen, right? And this kerogen, right, when the temperature, right, here you see when the temperature is not that high, they become kerogen, and when the temperature is getting warmer and warmer, when it comes to about 90 degrees, right, if that sediment layer get up to 90 degrees centigrade, then this kerogen will change into a liquid state, right? They start to form some sort of a liquid, right? And if the same layer going to be get even higher temperatures, maybe around 150 degrees, now this liquid form will change into a gas, right? So the solid become liquid and gas, right? So all these depend on the oceanography or the state of the ocean sediment, right? If the temperature is very low, like 30, 40 degrees in that sediment layer, that organic matter or that shale will be remain as is, nothing will happen, right? But if if that layer get right temperature, about 90 degrees or something above, then only they will start making liquid form, right? And if they get around 150 degrees, then we will start forming gas, right? So that is how actually this organic matter become liquid state, what we call now the crude oil, right, or the petrochemicals, right? They need to have the right temperature, not only the temperature, even the right pressure, right? Under that very high pressure, as well as the proper temperature, then will turn into the liquid form of petroleum, right? And in the higher temperatures, they become gas, right? So that's the story about how these crude oil are formed, right? So the original source where these petrochemicals are originated, we call the source rock, right? So that's, as you know, it's a solid form of sediment, and then we call the source rock, and then that become later into organic matter, right? Now this, when they start making this what you call the liquid form, we know that this oil is usually less dense, right? Than the source rock. I mean, it's a sediment layer. Yeah, they are still in the among the sediments, right? And this sediment layer, so since the oil and gas is less denser than the surrounding sediments, now what happened, they start migrating upward, because when they, I mean, in between the sediment, there are some pores, right? Minute pores, and they start migrating upwards, right? And when they get to upward, right, and there can be some hard solid areas or the hard rocks on top, which the sediment may be not allow this oil to be moved any further upward. And now what they start accumulating in this area, right? And like in the large amount of this liquid come to some area, and then they stop there because of the impermeability of the rocks above. Now this is called the reservoirs. All these oil being collected in these areas in large amounts, and they are called the reservoirs, right? Now that is how actually the oil reservoirs are formed in a layer which can be very deep in the ocean, right? Sometimes a couple of kilometers down, and that's how the oils are formed, right? So now if you go to the history, actually most of these large scale plankton blooms has been formed during Mesozoic era, if you remember this, right? In the geological time scale, the Mesozoic era, about 150 million years ago, right? So that was the time where the conditions was best for the black shale formation, right? Right temperature was in that time, right? So anything now we see in the, like we extract the oil and gas, they might have originated from any plankton blooms or active plankton blooms subjected to these temperatures 150 million years ago, right? So imagine, right? That's why the oil and gas resources, right? So they are not renewable resources, right? They can renew perhaps, but it takes millions of years, so and definitely not within our lifetime, right? So that's why it's not a renewable resource, right? And that's how, I mean, again, there are different areas in the ocean where they have this resource. Now you can understand that why there need to be the plankton blooms, which means these areas has to be upwelling areas mostly. Right? So now you can like make a map, mind map, why we get the oil and gas in some areas and why not in the others. Right? So if it is in the ocean, they have to be in the upwelling areas in particular, and they have to have the right temperature and the right depth or the right pressure for them to make this black shale into a source rock and eventually become oil and gas, right? But in the land, that may be the forest or right other organic matter that's formed into oil and gas, like in the Middle East. You see some oil and gas resources in the terrestrial environment as well, but we are talking here about the marine resource, right? Right. So that's how oil and gas are formed, right? And just to get an idea, what is this black shale look like? You see this is in the North Sea. You can see some black shale even in the coastal zone, right? So this is what we call this, the black shale. And that is the source rock, where when these rocks are subject to that temperature and pressure, will only form oil and gas, right? So as you can see, this source has more than 50% organic matter, right? Earlier I told you, if it is anything above 5%, right, and they call it black shale, which is likely to form oil and gas, right? This is 50% organic matter, which means they are likely to have or likely to produce more oil and gas. And that's why the North Sea area is one of the biggest oil producing areas, right? So there is oil and gas provinces, a huge amount of oil and gas in these areas. Because of this organic content in this black shale is very high, right? So I hope now you have some idea. So now when we have to explore the oil, when exploring the oil, then we have to look for that, what we call the pockets of oils where they have been trapped. You know, some layers of rocks, they are impermeable for the oil and gas, and call them as the pockets, right? There can be some pockets of oil that trapped, right? So these pockets are not small ones, they can be huge, large pockets, right, which trap the oil and gas. And when we are exploring the oil or gas, then you have to find these pockets, right? And that is where we need a lot of technology, because that can be for several hundred meters to thousands of meters down, or it can be a couple of kilometers down in the sediment, right? So you have to find the place where there can be these oil traps, right? So that's all about technology, right? You have to find this oil and gas in the very deep ocean, right? And that's where you need to do deep water, deep ocean exploration. I think in one of your presentations you have done, so you're looking for some mineral resources in the deep ocean, but mineral sometimes can be even in the surface, but these oils in many cases, they can be in a very deep ocean that you have to look for, right? So the whole idea of oil exploration, right? So we have to look for the reservoir rocks, or where the oil or gas can be trapped, right? So you have to look for this area. So that's where you need to find these areas with the technology, and you have to have the marine chemists especially the petroleum chemists, to identify the different types of layer of sediments in the ocean. In that sediments, they have to look for something called this reservoir rock, where oil and gas can be trapped, right? So you can imagine how difficult task this is going to be, right? So I think for us, finding a well with water, it's so hard, but it just 10 or a couple of dozens of meters down, but this is, we are talking about a couple of kilometers down, but underwater, right? So the more importantly, not like in the terrestrial environment, so we have to do everything underwater, right? Which we cannot go into, right? Right. So again, the whole idea of oil exploration is to find the reservoir rocks, right? To find this reservoir rocks, as I mentioned before, we have to use a lot of high tech, right? And that's where the seismic surveys come into play, right? These what we call the seismic surveys. That's where you use the high energy sound source, right, to get the different layers, right? To get some idea about the different layers in the deep among the sediment, right? It can be in the terrestrial environment as well, right? And also in the underwater, right? And as you would see in the left image, this is how they explore the ocean sediments, or rather the sediments. In this case, it's a terrestrial environment where they use something called the geophones, right? These geophones were vibrating or high energy device they use here, right? It's like a bomb, right? And then there are some detectors where they can detect this any returning waves. They go in deep into the sediments, right? And some of them bounce back from different layers of the sediment. So they have different features, different wave characteristics when they return. And these the receivers, right? So this is the vibrate. Actually, geophones are the receivers. They receive this incoming sound. The computers, very powerful computers, analyze these incoming waves, and they give some sort of a computer generated image, something like one in the right. For us, to you and me, it's just a black and white image like this. That's where very experienced geochemist and a geophysicist, actually, they have to find the source rock. Like they have to look for possible the source rock in this image, right? It's not something easy, right? They, by experience, they know this kind of as you can see, this dark layer here. So this can be a source rock, right? So this can be a source rock where they cannot get anything other than that, right? From this seismic surveys, they get some sort of a idea where can be this source rock. Of course, they can measure the distance from the top of the sea bottom, right? From the sea bottom to, so how deep it's going to be. And now, once they found these areas, they have to drill a couple of holes up to here, and one up to here, and like here, couple of holes, and see whether is there any oil here, right? So imagine how difficult task is going to be. So they have to drill up to this point, right? From that they can discover whether is there any oil. Chemical analysis, through the analysis they can detect. But again, they want to explore a couple of holes to see how much they have extent, right? Around this, they have to drill a couple of holes to see what is the extent of this. Otherwise, if it's small pocket, that's not going to be economically viable, right? So they have to look for a large oil pockets, right? So that's the very basics of oil exploration, right? In nutshell or in very brief, but this is very complicated story if you're actually going to do it in reality, right? So, right. I hope now we have some idea about what are these oil and gas and how they can be explored. But if you go a little bit further into the oil exploration, right, to do this one, like this is called a oil platform, right, deep ocean oil platform, or actually the oil production system, as you can see. So it's in this one, this case is not very deep. As you can see, there are some mountains behind. So which means this is a little bit of shallow waters, but some of these oil production systems can be in a very deep ocean, right? Several hundred to kilometers away in the very deep oceans, sometimes maybe a couple of kilometers deep. The ocean bottom is a couple of kilometers, and from there another couple of kilometers down where the actual oil pockets are, right? So we have to drill up to that point, and you have to set up this system where they are all these the pipes has to run from the bottom several kilometers, right? So imagine the technology in the world, right? And imagine where we are as a country, right? How much technology we have, and how much technology the world has, right? So how far we are behind the world, right? So that's why you as students or the future scientists, right, you have to think in different ways or think different, right? Now we are even afraid of getting this COVID vaccine, right? Believing that we don't know what is there, right? So if that is the way that we are thinking, right, how we are going to explore the deep oceans, right? So if you are so pessimistic, right, so passive in this sense, right? So innovations is always something, right, risky thing, and it's a vulnerable thing. Always there is a vulnerability, there's a huge risk, but that's how the scientists take that risk. Otherwise there won't be any innovations, right? So anyway, we are far behind when compared to the world, even compared to the many neighboring countries. We are very far behind when it comes to the technology, because we are very passive into these things, right? Right, anyway, so this oil explorations going to be really of course difficult, as you can understand. It's going to be very costly, right? A single meter drilling might cost about 10,000 or more, right? Maybe today it's more than that, 1 meter, right? So imagine if they are going to drill 2 kilometers, 3 kilometers down, how much investment that they have to do, right? It's it's millions, right? It's several millions they have to spend on oil exploration. But as you can imagine, when they explore, when they drill up to that source rock, there won't be anything sometimes, right? It just may be oil pocket, or it may be a called, sometimes it's a dry hole. Though it could be oil, but that oil must have not there, because with the time they still spread around the ocean. Even they come to the surface little by little, and there won't be anything left in the ocean, right? So they can be a dry hole, but the whole investment will be lost sometimes in this oil exploration. But if they found something, and that the whole cost can be covered, not only then it's a huge profit as well, right? So all depend on how much oil they are going to be. But still some companies, the big companies, they take that risk. They invest on this, right? Without that investment, there won't be any return. But if they succeed, it's a huge investment. If we don't, it's a huge loss, right? So they have to decide whether that they take that risk. But of course, now there is a lot of technology. With that, they can, like with some certainty, they drill actually these holes, not just blindly they do it. They have to best scientists or the explorers in the world. They hire them to check that, right? Right. So that is in very basically how you do it, right? But other than that, they have to to accelerate or to improve the recovery of oil. They have to use other technologies. For example, like when the oil production system, that platform actually is called oil rig, right? RIG, rig, oil rig, or the oil platform. And if this is the platform, sometimes they have to pump some steam around this pumping area to make it warmer, which force this oil to go through this. I mean, this rock can be still some permeable rock, but so you have to send some pressure through these the rocks to direct this oil into the pump or the pipes and in pump to come to the oil production system or to the oil rig, right? So imagine you have to all these in the surface, right? No one can go down. So no one has seen even where this oil actually, but they do everything from the surface, from a ship or from the oil rig, right? So everything done remotely. So imagine, right, how you can do it without a single man in the bottom, right? All this drilling to making a production system, they all done remotely, right? That's how the people have developed the technology to do this kind of a job, right? So anyway, once these production systems are formed, now this production system of the oil rig can be middle of the ocean. Then they have to either make this kind of a pipeline from all the way to the oil rig to the coast or to the area where they can store, they go for the refineries, right? For the further processing, right? So this is the Alaskan region. They have a pipeline. So this the oil that's extracted directly pumped into the refinery from the production to the refinery, right? Or sometimes if it is too far or too expensive, they will use oil tankers, right? They use some ships, large ships to transport this oil from the oil rig. The production system has some storage, and from that storage, they transfer them to the tankers and send them to the refineries. And even from the refineries or from the the production systems, they use this kind of oil tankers, right? So the ship purposely built for carrying crude oil or different types of oils, right? The whole hull is a hollow, or the space you can fill with the oil. You see, this is a oil carrying ship with all these pipelines, right? All these are high-tech devices actually. They can pump directly from the sea, right? They have all the facilities to pump from the sea into the refinery, right? Even in Sri Lanka, you know, there is a, in the about 5-6 kilometers from the shore, little away from the Colombo port, there is a buoy, a boya, right? With this tap line, which is closed. Once the ship arrives, they open that tap, connect to the ship, and they directly pump from there to the refinery, and it comes directly to the Sapugaskanda, or wherever the storages are, right? So that's how these systems work, right? Now, when they come to the refinery, right, this kind of refinery system, then they have to go for a distillation process, because they have to separate different chemicals into different elements, right? So this is done in a oil refinery, which energy also costs a lot of energy to use this as oil refinery. It's a complete distillation plant, right? And the distillation system, under different temperatures, as you can see, the crude oil sent from the bottom and through the distillation system. The first things to come is the gas, what's called the petroleum gas, right? Petroleum gas, we call the LPG, right? Liquid petroleum gas, something that we use for cooking. That's come from that is the first thing to come from the crude oil, right? So any crude oil that import to Sri Lanka, right, when they started in the refinery, they produce gas, right? The most of the cooking gas we get in Sri Lanka actually come from this oil refining process, right? And some of the gas, of course, they import, but the part of the production come from through these refinery, right? The next thing to under 20 degrees, they produce the gas, right? In the first thing to come is the gas, then the gasoline or the petrol, then you have the kerosene and the diesel and the fuel oil, or we call the heavy oil. I don't know whether you heard about it. It's fuel oil or the heavy oil. That is the fuel used for the ships. They are heavy, but that can be used for like heavy engines, like something in the ships. They are cheaper compared to these things, but they are very thick, not like in the normal car. Cannot be operated in this fuel oil. It's very thick. You need a specific engine which can run in under very viscous environment, right? So other than that, you get this lubricating oils that used for like lubricating the engines. Then the paraffin wax, all these different waxes made of these things, and a lot of other chemicals are formed, including plastic. You know, the plastic is actually produced from the waste, or anything left from the refinery process. One thing left is actually the tar that used for the paving the roads, right? The road tar, right? So basically nothing is wasted. Even the anything left from this refinery forces, they have some purpose, right? So this whole bunch of chemicals they have that can be used for many different purposes. Like the whole world actually now depend on this petrochemicals, especially the hydrocarbons, because they have multiple uses, from cooking gas to car fuels to jet fuel, right? The best, the fuel actually is used for jet, right? The more pure form of a fuel, right? So that's the process. So this process of distillation actually was invented by a scientist called Abraham Gessner. Actually, he used this distillation for distillation of paraffin actually, and later on the technology was used for refining all different the system. In the previous video as the gushers, right? These refining systems, that's the English people use the term, the gushers, but now we call the refineries, right? So this is the situation today, is where the most of oils and gases are. You can see some of the oil and gas production systems are, most of them are in the terrestrial environment as well, right? Right. The legend is the green are the production systems, right? Different regions in the world. Unfortunately, you see there is no much oil production system around Sri Lanka, but there is some from the Indian side. But in India, in the west coast, they have a lot of gases. But in the east coast, it's not highlighted here, but there is some little bit of around here, but they're not, as you can from the color, it's not like a huge resource. Right. So now, if you come to a little bit of politics, you know, this oil and gas production is very much something to do with politics as well, because since there's a lot of money behind, that's a lot of politics behind as well, because these companies are extremely powerful, because the companies has a lot of money. They can do anything, like the Shell is one of the leading oil and gas producer. Then there's another called BP. If you have heard about, it's called the British Petroleum. It's BP and Shell, and the others. I forgot about the other names. Likewise, there are several few companies actually who lead in the world production, right? They have enormous power, so they can decide on what could be the prices and all these things, because you know, few cents increase in the oil can be a huge profit for them, right? Because the billions of barrels of oils being used daily, right? So $1 increase, not $1, a few cents, maybe millions of dollars income for them, right? So that's where they have used a lot of politics as well, especially like arbitrarily reducing the production to make the price hikes, right? And then likewise, right? And on the other hand, as I mentioned, the lot of the material that we use every day have also come from oil and gas. For example, the CDs, right? They are because they are plastics. So almost all plastics, the source material actually is the hydrocarbons. And fertilizers and pesticides come from the base material, and some even food additives, right? But majority of oil used for the fuel, right? We know something called the OPEC, the Organization of the Petroleum Exporting Countries. They have the like the power of deciding how much oil to be produced and what could be the prices. And this is led by the Saudi Arabia, which is the largest producer in the world. But at the same time, US, Canada, Britain, even the Russia, Soviet Union previously, they are the large producers in the world, including Australia as well to some extent. They have large oil production system, right? So that's how these systems work, right? So and the oil use, actually the US led for most of the time. They are the biggest consumer in the world, as you can see from the color. The darker the color, which means they use more oil and gas, as it's in the US and Canada use most. Sorry, yes, US, and then from the global supply they use a lot of right. And but now China taking the lead. They use more oil and gas because of with their like a commercial state, right? Right. Now, if we look at the oil and gas production throughout, you see they started just before 1900, the oil and gas, and see how it increased in an exponential increase in the oil and gas production, right? Maybe up to 2000, right? Now you see, and it's gradually started decreasing, right? We have come to a peak around 2000, 2000 year of the millennium, and then plateau for a while, and now it's in a phase of declining. And you would see by 2050, 2060, 70 something, there will be very little oil. And if you continue the present rate, right, most of the oil will be disappeared from the world, maybe around 50, 60s, right? Which means most likely within your lifetime, right, there won't be much oil left, right? Which we have to look for the alternative source, right? And the oil prices also has gone up, but you know, this oil price again depend on the demand, especially under this the COVID situation. The oil demand has decreased and the prices came down. But again, after post-COVID, now there's a lot of economic blooms on the world, and they have like accelerated again production. But with some with the competition, the price still not very high, right? But they're likely to increase the price to some extent, right? Right. Now with, you know, now other sources, right? It's oil, other than the oil and gas, right? Now they are looking for other sources, like in the just like a black shale, there are other sedimentary rocks where they can be used for for energy production, something like the tar sands, they call as the tar sands in Canada. They can be, or they also can be harvested or extracted for production of energy. So still we have, large resources of coal, right? Because now a lot of countries have stopped or reduced their coal usage because of environmental issues, and still there is a huge coal deposits. But other than like a tar sands is another form of sedimentary rock which can be used for energy production. And if you remember, we talked previously something called the methane hydrate or the methane hydrate or dry ice, something like not dry ice, methane hydrate also can be used for some energy production. Still, there are huge resources of these as well, but we don't know how this can be used for as an alternative source, because methane hydrate is a solid form. They cannot be directly used for like for a car engine. Otherwise, you redesign the car engine, right? But especially, the greenhouse gas production due to the increase in burning of fossil fuel. Now, a lot of countries has a lot of issues talking about, especially the coal burning causes a lot of environmental issues. Then the oil as well, producing carbon dioxide or the greenhouse gas. The whole world is now looking for renewable energy forms. Right? Sri Lanka also targeting, but the government has a policy to go for like a 70% renewable, which is a good move. But the thing is, whether it's something practical, that's something we have to think of, because not an easy task, right? Not an easy task to go for 70% renewable. Especially, we talk something called the firm energy versus non-firm energy, like oil and gas or the coal, gas, they all firm energy. You are pretty sure as far as you have the oil and gas, you can get the energy you need. But others like solar, wind, right, or the waves or tidal energy, all these are, even the hydropower, they are not firm energy, because you don't know whether they can, you are not quite sure of whether you can get the necessary amount of energy you need, because if there is no water enough in the reservoirs, you can't produce enough, right? If there is no wind, no production, no solar, no, like these days it's very overcast, and there's no production from the solar systems, right? So likewise, so you will have a big issue. Okay, that thing has to be considered again. Anyway, the oil demand has increased substantially in the world at the last time, but now it's again a lot of countries looking for the alternative sources, right? As you can see now, the oil consumption in the world, China leading. I think this is the energy, actually, the oil and gas energy, because gigawatts, how much energy is they're using from the oil. China leads, United. But if you look at the history, there was a long time the US has been leading this, but now China has taken over. It's a couple of times US and China has been battle, but now China has leading the whole world. Right. So now when come to the production, 34% by, I don't know the present situation, but by 2000, about 34% of the petroleum and 28% natural gases has come from the seabed, which means about a great proportion of the energy or the hydrocarbons come from the ocean. But these resources are heavily extracted, and then the future of the sediment or the resource is going to be questionable, right? So, which means now this is a marine resource, as we all know. So it's because it's come from marine sediments, all this the resource, right? Right. On the other hand, in the terrestrial environment, the plants, the forests, they turn into the oil and gas in the terrestrial environment, whereas the plankton and the animals turn into oil and gas in the marine environment, as we know, right? So okay, so in the naturally, right now, there is a difference, the natural gas versus LPG, liquid petroleum gas, right? Anyone of you know the difference between LPG or the liquid petroleum gas and the natural gas? Anyone has any idea? Right, I'll come to that one later on. Right. So before that, if you go a little bit further into the oil exploration, right, and as you would see, this is the oil. This is, if you are doing oil exploration, so you're looking for this, the source rocks or the oil pockets, something like here, right, where they have to put this platform, oil platform, or the oil rig, and you have the oil well, right, and you might need to sometimes pump some steam to accelerate this process, right? So it is obviously drilling in the ocean going to be very expensive than in the terrestrial environment to make in this kind of oil rig. It's called the offshore oil platform. So it can be definitely anything deeper than 100 meters, sometimes can go up to 3-4 kilometers even, right? And right. So this is the situation of the natural gas, coal, and oil. Right? This is oil, coal, and the natural gas. Right? The conventional use. Right? There is huge amount of natural gas as well, large amount of coal deposits as well, and the oil. As you can see, the oil and oil going to be the first to disappear, then the coal and the gas, because the oil is used frequently than the other two, so they're going to disappear earlier than the other two, right? So as I mentioned before, methane hydrate is another likely source which is in a large amount of or the large amount of methane hydrate in the deep ocean as well. We can extract, we can directly burn them because it's a lot of energy source. But as I mentioned before, but practically how we can use this is the question, because they can easily burn it just in the outside, even as you can see. Not like we have to redesign all these engines if you are going to use it, right? Now, that's the story about the oil and gas, right? So if you if you come back to the Sri Lankan situation, oil and gas exploration in Sri Lanka, as you can see, there's a big ship here, right? It's a ship, but also it's a that ship. This kind of a ship actually used for oil explorations. You can see what kind of a ship it could be. It's called Genstech. It's a Japanese actually design, Japanese built a ship. This called actually they made this as a scientific research vessel, right? So imagine how much technology is being used in this ship, right? How big it can be. You can see there's a helipad here. Think of the size of the helipad and the size of the ship, right? So you can put a helicopter here and then think of the size of the ship, and this being used for exploration. But when it comes to the Sri Lanka oil exploration, actually we also use this, one of the advanced ships in the world. It's called the 6th generation ships because it has the most advanced technology for the ocean exploration, and the same ship was used in oil exploration in Sri Lanka. So I had the advantage, or I had the opportunity to actually to go into the ship when they were doing oil exploration, and back in, if I remember, 2014 or 2015. If you can see here, this is me in that same ship where we went during the oil exploration in the we call the Kaveri Basin, that's off the Mana, right? During that time, right? So, if very briefly, if you look at this oil exploration in Sri Lanka, right, what we have done is one of the foreign company has done some seismic surveys around Sri Lanka, right? Some sort of a seismic surveys they have done just to see which areas are likely to have that source rock or the oil pockets, right? From the seismic surveys, they can get some indication, as I have shown before, the computer generated images. You can think of where there can be oil and gas, and then from that they have like a block out some areas, like they have given some let with M and C, right? This block out plan is like this. These areas has been blocked out, and now the government is trying to like give the explorers, whoever willing to do exploration in these areas, they will give this seismic survey data. If they are interested, they can pay some money to Sri Lanka and they do the explorations. And if this exploration successful, so they will sign some sort of a agreement with Sri Lanka and that company, or who is the explorer. They will decide what is the percentage that they are going to give Sri Lanka and what is the percentage that they are going to get. Right? So that's basically the rule or the deal. So of course, these deals are not very much clear. These deals are actually go with the government and the oil explorers. In many cases, they are sort of secret documents. Not very clear the percentages, right? And what are their agreement is not very clear. But anyway, that's how this work. We don't know how much money in the back door in these deals, but anyway, it's not something for us to discuss here, but that's how things work. So accordingly, this area, there was some oil exploration, right? As you can see in these dots, these areas has been already surveyed in this one in particular, right? By sorry, this one, by Indian oil companies called Cairn, 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 India actually. So imagine, so India is that rich. Indian companies, it's actually a British-owned company. They bought it. One of the Indian company, they bought it, and they do the exploration. They spend all the money, millions of dollars for this exploration. And then Cairn, Sri Lanka is actually the project. They started oil exploration in Sri Lanka. And this is the whole blockout plan on the right side. In Sri Lanka, there is a government institute called PRDS. It's called the Petroleum Resources Development Secretariat, right? PRDS, Petroleum Resources Development Secretariat. They are the one who has all the legal power to do the explorations and making all the decisions on this. So this is a blockout plan. Now they have already done seismic surveys here. They have done some of the seismic surveys here as well, just to block out. But whoever the companies taking these blocks, they will do again the seismic surveys further, get further details, or if this information is not enough, they will do another seismic surveys, and then they will do the drilling, right? They will do some drilling for looking for some the oil, right? So that's the basic process. Now they have especially looking at 3 ocean bases, one in the Mana, that's by the Cairn, the block called the M2, right? There are other blocks as well. This block has already been explored. There's a Cauvery basin is here, right? There's another southern basin as well in this area, the Cauvery basin, the Mana basin. So this is a Cauvery basin, the Mana basin here, and there's a southern basin as well. So this has been already explored. Right. So what happened here? Right. They have done this exploration here, and these are the seismic survey data, right? As I mentioned, for you and me, we cannot understand anything. It just look like a colored image, but experienced geophysicists and geochemists, they know how to interpret this data with the support of computers. From these images, they can decide where there can be a possible areas where oil can be, or the oil pockets can be. Then they have to drill up to that pockets, right up to here, and they have done this oil exploration in this area, in the Barracuda, Dorado, and right, Dorado North and Dorado. These are the 3 holes they have drilled, right? Barracuda, that's the names they have given. Now Pesale, you might know that's in the Mana region. Some of you might know this area they are going to explore in the future as well, and likely area another, but this has already been explored. Seismic surveys already done You see, some of the seismic data says well state plugged Pesale exploration, they have found that some gas, but most of the holes called dry holes, right? Which means there is no any oil and gas, but there can be some source rock there, but there is no any oil and gas. They might have already disappeared. Right? So, and some gas here as well in few locations. Barracuda, this is the can exploration. In many cases, they are dry holes, which means there is no production level, but there is some platform, sorry, the holes where you can still tendency, some potential for oil exploration. But what happened in this exploration actually, they drill couple of places, as you can see. Some of are dry, but they drilled couple of holes and they discovered that this amount of oil in this area, sorry, it's not actually oil, they have gas, right? In most of the cases around Sri Lanka, they found a natural gas. So this gas actually amount that here they estimated it's not really economically viable, go for production level, right? But you might have recently, like ministers in many cases or many times, they were boasting about we have the natural gas, they are going to start production. But I mean, just after even the oil exploration in 2015, I think they have even planned for like laying the pipes from the Mana Basin to Colombo. Even I was involved in some of these work, but later the company who explored, they gave up because that is not economically viable. But when the oil price in the world, oil and gas price is going to high, so there is a possibility to earn a little bit of money from that, but it's not going to be a huge resource, but it can be economically viable. But if it is the oil price going to be high, maybe in the future, right? But otherwise not going to be really worth, right? That's the situation, right? Though the ministers or the government is boasting about the oil and gas production, but that the oil and gas amount we have is not really, though at least the amount that we have explored is not really enough for like going for a production level, because the cost as well as the environmental cost, and if you put everything together, it's going to be a huge cost, which might not get a big return, especially the company who do the exploration. They are the one who are spending money, right? This again, as I mentioned, there can be a deal between the company and the government. The government will get very small fraction actually, because they have to cover all the expenses, plus they have to earn profit, which a greater proportion will go into the company, right? So even we explore the oil, if we have the oil and gas in some amount, still we will get a little bit of money, but much of the income will go to the explorer. That's unfortunately that's the situation. But the government or the companies in Sri Lanka is not in a position to do exploration, but it's a huge investment. And for the Cairn India who did the exploration, it's a huge loss for them. The billions of dollars for nothing actually. So now the dry hole, they have just sealed it and abandoned. Right? I don't know what is the legal situation with that, whether it's still owned by them or once they abandon, whether it's going to the government or not. Right? Still, that the tube which has gone to the bottom has it still close the tap. You can open it, but it doesn't mean that it's going to produce the oil. It's just the exploratory hole. Then if you are going for a production system, you have to drill it again properly. You have to set up a production system with the oil rig or the oil platform. You have to set up that one, and then only you have to use, and then can start producing the oil, which is a big task, right? So, okay, that's the situation. Now, if you come back to my early question, the difference between the LPG and natural gas, who has the idea what is the difference between the LPG and natural gas? Right? I have spoken almost 1.5 hours now, non-stop. If any of you have idea, right?